Okay, so here we're going to explore the one really fundamental difference between solving inequalities and solving equations. Let's consider sort of a statement of the obvious. 3 is greater than 2. Now, if we multiply both sides of this inequality by a positive number, like 5, we have 3 times 5 on the left and 2 times 5 on the right. Have we preserved the direction of the inequality? Well, what is 3 times 5? That's 15. 2 times 5 is 10, and 15 is certainly greater than 10. So the direction of our inequality has stayed the same throughout. But let's consider multiplying both sides of the inequality by something negative. What if I multiply both sides by negative 5? So now, on the left, I have 3 times negative 5, which is negative 15. And on the right, I have 2 times negative 5, which is negative 10. So is negative 15 greater than negative 10? No, in fact, it is less than. And if you are ever confused at all, especially with negative numbers, always just think of less than as to the left of. So if you're on a number line, negative 15 is to the left of negative 10. So this is a fundamental difference, right? We didn't really have to worry about multiplying or dividing by negatives with equations, but we certainly have to worry about it with inequalities. So the rule is the minute you multiply both sides of an inequality or divide both sides of an inequality by a negative number, you must change the direction of the inequality. So right here in the second line, I would change that to a less than. But after that, nothing really is different. It's a fundamental difference, but it's sort of a small one, really. So let's take a look at some actual linear inequalities. So what if we have something like 3x minus 4 greater than or equal to 11? So I can add 4 to both sides of this inequality. Remember, adding and subtracting, I don't have to worry about changing the direction. So I get 3x greater than or equal to 15. I can divide both sides of this inequality by 3, and because it's a positive number, I keep the direction of the inequality the same, and I end up with x greater than or equal to 5. If I graph that solution, I can put the 5 in the middle and a couple tick marks either side, so 3, 4, 5, 6, 7. I'll have a solid circle because it's greater than or equal to, and I'll shade everything in to the right. Now, when I check my solution, I can check 5 to make sure that the left-hand side and the right-hand side of the original statement are equal. So 3 times 5 is 15 minus 4 is 11. So I get an 11 on both sides. So I know I've got the right boundary value. If I check 6, I have 18 minus 4, which is 14. That's certainly greater than 11. And if I check something that's false, it's not part of my solution, like 0, for instance, I get negative 4 on the left, and that's obviously not greater than or equal to 11. So I've got everything correct here. Let's take a look at another one, though. 8 minus 2x greater than or equal to 2. So most students are going to solve this by simply subtracting the 8 from both sides, and that's fair enough. There's nothing wrong with doing that. It does lead us to a negative coefficient, and now you really have to have your red flag up and be on guard, because the next step here is going to be to divide both sides by negative 2. If I divide the left by negative 2, I'm going to get x on its own. If I divide the right by negative 2, I'm going to have a negative divided by a negative. That's going to be positive 3. And because I'm dividing by a negative, I have to now change the direction of my inequality. Because there's essentially 2 steps going on there, I'm changing a sign, right? The negative 6 on the right became positive 3, and I'm changing the direction of the inequality. It sort of leaves you open to a high probability of making a mistake. So really be on guard here and really check your solution, right? Because if I graph this solution, I can have, let's say, 1, 2, 3, 4, 5. My 3 is in the middle there. It's a solid circle. This pen causes me problems. It's a solid circle. I'm going everything here to the left. So when I check 3, remember that's my boundary value, I get 8 minus 6, which is 2 on the left, 2 on the right. So that's fine. If I check 0, right, I've graphed it as part of the solution, right? 0 is definitely part of that solution. So when I plug in 0, I should get a true statement. 8 minus 0 is just 8, and that is greater than or equal to 2. So I've got it correct there. If I check something that's not part of the solution, like 5, I should get a false statement. 8 minus 2 times 5, that's 8 minus 10. That is negative 2, and that's clearly not greater than or equal to 2. So let's take a look at one more example where you have a little bit more flexibility in how you solve it. So let's say we have 3x minus 4 is greater than 5x minus 8. So the first step usually in solving an equation or inequality of this kind is to collect the like terms, the 3x and the 5x. You want to put those both on one side. So we've got some choices here. What if we subtract 5x from both sides? In other words, decide to collect the x's on the left. So let's call that option 1. If I subtract 5x from both sides, I'm going to have minus 2x on the left. The 5x will disappear from the right, and I'll just have the minus 8. Now I can add 4 to both sides. If I add 4 to both sides, the minus 4 disappears, and I end up with negative 8 plus 4 equal to negative 4 on the right. And now I have to divide both sides by negative 2. When I do that, I have to change the direction of the inequality, and negative 4 divided by negative 2 becomes positive 2. Okay, so that's one option. Let's just put that in its own little box. What's option 2? Option 2 is that I choose to collect the like terms on the right. In other words, subtract 3x from both sides. If I subtract 3x from both sides, I just have negative 4 on the left, and I have 2x on the right, minus 8. Now I can add 8 to both sides, and then divide both sides by 2. Because I'm dividing by a positive, I don't have to worry about a sign change, and I don't have to worry about changing the direction of the inequality. If you look, all three lines have a greater than, greater than, greater than. Nothing has changed there. There's one sort of additional step here, and I mentioned this in the last video, which is that 2 greater than x is the solution, but it's just not sort of the standard way we would normally write that. We would normally write that in the reverse order as x is less than 2. And at this point, notice that both options have the same solution, x is less than 2. So, you know, it's up to you which way you want to do it. You should be comfortable doing it both ways. My preference, if I was solving this inequality, would be to use option 2, because I don't have to worry about the step where I divide by a negative. That, in my opinion, just leads to a higher probability of making a mistake. I see it in students' work, and I see it in my own work. So I would say you probably want to do whatever you can to avoid dividing by a negative. And, you know, sometimes you don't have a choice, but in this case, we clearly had a choice. Of course, we'd want to do the solution and then check the solution. So in both cases, we have x less than 2, so we'd put a 2 there in the middle, 0, 1, 3, 4. And, you know, this activity here is more than just communicating. It's actually giving you a nice way to check your answer, because it's sort of obvious what you have indicated here. 0 should be part of the solution. If you go back up to the original inequality, when you plug in 0, it has the effect of eliminating anything with the x. So you just get negative 4 is greater than negative 8, which is true. If you plug in 2, that's the boundary value, you get 6 minus 4, which is 2, and 10 minus 8, which is 2. So in other words, the left-hand side and the right-hand side are the same, which is what you want for a boundary value. And then when you plug in something like 3, you get 9 minus 4, which is 5, and 15 minus 8, which is 7. 5 is not greater than 7, and clearly 3 shouldn't be part of the solution, and it's not, as we've graphed it. So at this point, you know you've done everything right. But be aware of the choices that you make and the implications of that, whether it leads to a higher chance of making a mistake or not.